Hi there. Welcome to our midsummer edition of Ask the SOO. Hope you're enjoying your summer so far. And we haven't had any hurricanes so far, which is always a good thing. But we're going to continue to talk a little bit about hurricanes in this month's episode. Welcome to our second and final installment of Hurricane Hazards Fact or Fiction. If you recall, last month we discussed the hazard of storm surge and waves. Remember that storm surge is the deadliest part of a hurricane. This month we're going to talk about two other hazards within a hurricane that can also be deadly and destructive, and that is winds and tornadoes. Winds are especially important because they define the strength of a hurricane, and in fact determine if a storm is a hurricane at all. Tornadoes can also occur within hurricanes themselves. Freshwater flooding is the final hazard, but since that's not a big threat here in this area, we're not going to discuss it. Before we get into the specifics of wind in a hurricane, let's talk about what causes wind. In this schematic, H represents high pressure, L represents low pressure, and the curved green arcs are what we call isobars, lines of constant pressure. One of the main forces that cause air to begin to move is the pressure gradient force, which goes from higher to lower pressure. Now, to oppose that force is something called a Coriolis force. The Coriolis force exists because the Earth rotates, so it acts in the opposite direction of the pressure gradient force. We also have frictional force as wind interacts with land or water or anything that can cause friction. The frictional force tends to act to slow parcels down and also makes them turn a little bit more towards lower pressure. There are lots of other factors that are involved as well which aren't shown on the map, such as centrifugal force, centripetal acceleration, topography, and many others. All these forces combine to make the wind flow nearly parallel to the high and low pressure, but slightly turned in towards lower pressure. Therefore, the winds flow counterclockwise around low pressure in the northern hemisphere. Now, in a mature hurricane, the central pressure is very low, so there's a lot more isobars and they're a lot tighter together, as shown in this schematic. The tighter those isobars are together, the stronger the wind. So it's time for our first fact or fiction statement. Hurricane winds are classified by the Saffir-Simpson wind scale. Fact. We should all know that by now. The Saffir-Simpson hurricane wind scale rates hurricanes on a category from 1 to 5 depending on their wind speed. The lowest category still has winds of 74 miles per hour or higher, and so is still capable of producing moderate damage such as roof damage, blowing down small trees and large branches. But as we go higher, we reach categories 3, 4, and 5, which are devastating to catastrophic. Hurricane Hugo was a Category 4. This short animation put together by the Comet program gives a conceptual idea of the damage that hurricane winds can cause, ranging from Category 1 to Category 5. You can see as we get higher into the categories, starting with a Category 3, which is where we start to consider a hurricane major, we can get some devastating results. And by the time we get up to a Category 5, which is winds greater than 157 miles per hour, there just simply isn't much left. Okay, next statement. Fact or fiction? The strongest winds of a hurricane are found in the eye. This is fiction. In fact, there are often very light winds in the eye, which is the center of the hurricane. The strongest winds are actually found in the eye wall, which are the thunderstorms that are just outside of the eye. There can also be strong winds in the rain bands that extend outward from the center towards the edge of the storm. The satellite image on the bottom shows a hurricane from the top down. You can see in the eye that there's not a whole lot of clouds, but in the eye wall there's the bright tops of very tall thunderstorms. Next statement. Hurricane force winds can occur even beyond 50 miles from the eye. That is a fact, and let's look at Hurricane Katrina from 2005 as the poster child. On the morning before the storm made landfall in Louisiana, hurricane force winds extended 90 miles out in both the northeast and the southeast quadrants of the storm. They were 50 miles in the southwest quadrant and 75 miles in the northwest quadrant. You can see completely across it was over 150 miles. The tropical storm force winds extended out even farther, up to 320 miles across. This is why it's so important not to concentrate on just where the center makes landfall. Let's turn our attention to tornadoes. Fact or fiction? Most tornadoes occur within 100 miles of the eye. That is fiction. In fact, a large number of tornadoes occur well away from the eye. Here's a graphic that's taken from Easton et al. 2012. This looks at all landfalling tropical systems from 1997 to 2008. He found tornadoes up to 400 miles away from the center. Notice also that most of the tornadoes form to the northeast and east of the storm. Okay, final statement. Fact or fiction? Most tornadoes spawned by hurricanes form near the coast. This is fiction. Here's a map taken from Edwards 2012 of all the tornadoes spawned by hurricanes and tropical storms from 1995 to 2010. Note that tornadoes have been spawned as far inland as Indiana. Also notice the large amount of tornadoes in coastal South Carolina and Georgia during that period. We are susceptible to these tornadoes, especially from storms that move in from the Gulf. Most were EF0 or EF1, the smaller dots, but some were EF2 and EF3 represented by the larger blue dots. Fortunately, there were no EF4s or EF5s. Thanks once again for joining us, and we hope to see you next month, where we're going to talk about something a little bit different: wake lows and gravity waves.